Okay, so what I have with me to do this is my trig table and my sine table. And I'm just going to be working with sine in this video, and then in class you'll work with sine, cosine, and tangent. Okay, so in the last video I talked about the domain and range of inverse sine. And so I'm going to write that right here as review. So my inverse sine has domain -1 to 1. In other words, I can put in any real number between -1 and 1 and expect to get an answer. If I plug in a number that's smaller than -1 or larger than 1, I'll get an error. I'll get like a domain error in my calculator. Because sine cannot be bigger than 1, so I can't take the inverse value of the inverse of something bigger than 1. And my range is from -pi/2 to pi/2. So I cannot get an output that's going to be smaller than pi/2 or -pi/2 and larger than pi/2. So what goes into the inverse sine is opposite over hypotenuse, and what comes out is the angle. Okay, the values that go into inverse sine are opposite over hypotenuse, and what comes out is the angle measure. The angle measure is in quadrant 1 or 4. I can't get quadrant 2 or quadrant 3. And I'm going to remember this because when I'm looking at my trig table, there's some dark boxes on sine that starts at sine and goes over to pi/2. And then it goes on the other end from 0 to -pi/2. So if you roll this up, the two boxes connect and you get the full thing. Okay, so let's evaluate inverse sine of 1/2. So this is how it works. In my sine table, or in my trig table, I have sine. And I go across the table till I find 1/2 in the sine row. It has to be in the dark box. And I look up and I see pi/6. Okay, so inverse sine of 1/2 is pi/6. Okay, inverse sine of -√3/2. So I look in the table until I find -√3/2, and it's in the dark box. So the first -√3/2 is not inside the box. Okay, I keep going and I find it at minus. I look up, now I have to use the negative ones because I have to be between -pi/2 and pi/2. So if I choose 5pi/3, 5pi/3 is greater than pi/2, so I'm not going to get that. I'm going to get the corresponding, the coterminal angle that's negative, that's between -pi/2 and pi/2. Okay, so there's inverse sine of -√3/2. Inverse sine of 1. So I go in my trig table until I find sine equals 1. I look up, and my angle is pi/2. Okay, now I'm going to do something a little different. I'm going to take inverse sine of pi/4. Now, I work from the inside out. So sine of pi/4 is 1/2. And so now I have inverse sine of 1/2. So I go look in the dark boxes, and I find that 1 over the square root of 2 corresponds to pi over 4. Now, since pi over 4 is between minus pi over 2 and pi over 2, I just get pi over 4, okay, because it's in the range of inverse sine. But that's not always going to be I'm not always just going to cross off. So here, I look at inverse sine of 7 pi over 6. Okay, so I look up 7 pi over 6, and that is minus, sorry, I'm looking right here, and that is minus 1/2. Okay, is that right? Yes, okay. So I'm going to find the inverse sine of minus 1/2. So I find minus 1/2 in the black boxes, and so there's only one minus 1/2 that's in the black box, and it corresponds to minus pi over 6. Okay, and minus pi over 6 is between minus pi over 2 and pi over 2. 7 pi over 6 is not between minus pi over 2 and pi over 2, so it cannot be returned as a value of the inverse sine function. Inverse sine of 5 pi over 3. Again, 5 pi over 3 is in the fourth quadrant. It is going to give me negative square root of 3 over 2. Now when I look up negative square root of 3 over 2 in the black boxes, it's in the same box as 5 pi over 3, but 5 pi over 3 is not between minus pi over 2 and pi over 2. That means I need to take that negative pi over 3. That is between pi over 2 and negative pi over 2. So minus pi over 3 can be returned from an inverse sine function, but 5 pi over 3 cannot be returned from an inverse sine function. All right. Now, if I switch it the other direction, I don't have to worry as much. So I look up positive 1 over the square root of 2, I get pi over 4. And sine of pi over 4 is 1 over the square root of 2. So when the sine's on the outside, it does just cross off. I'm going to go ahead and do it the long way, just to convince you. So inverse sine of 1 is pi over 2, and sine of pi over 2 is 1. I have one more. Inverse sine of sine of inverse sine of minus square root of 3 over 2. Minus the square root of 3 over 2 is going to give me minus pi over 3. And then sine of minus pi over 3 is minus the square root of 3 over 2. So if the sine is on the outside and the inverse sine is on the inside, I do get to just cross them off and write down the inside. But if the inverse sine is on the outside, I need to be a little more careful than just crossing off. Okay. Now for the next few exercises, I'm going to be using the sine table. And I'm going to be giving the angles in degrees instead of in radians. So theta corresponds to a point on the unit circle that is minus 0.6947 and 0.7193. Okay? So if I use inverse sine, so remember that cosine equals x and sine equals y. So if I take the inverse sine of this measurement, I'm going to get an angle measure. But because x is negative and y is positive, I'm going to be in quadrant 2, where x is negative and y is positive. So I'm in quadrant 2. Well, I look in the sine table for this 0.1793. So look in the sine table for 0.7193, and I find the corresponding angle to be 46 degrees. 46 degrees is in quadrant 1, so I know that this cannot be the answer. So what I do, what that means is that 46 degrees is the reference angle, first quadrant reference angle, and I need to find the actual angle. So I'm going to take 180 minus 46 to get my angle measure. So theta is actually equal to 134 degrees. So now for the next one, theta is going to correspond to a point of minus 0.8746 and minus 4848. So I want to find theta. So this is x and this is y. So inverse sine of minus 0.4848. Okay, I look in the table for 0.4848 and I get 29. So inverse sine returns 29 degrees. But x and y are both negative in quadrant 3. So I need to find a quadrant 3 angle. So the reference angle is 29 degrees. So the angle that I'm looking for is 180 plus 29 degrees, which is 209. So that's the theta that I'm looking for. Last one. Theta corresponds to a point on the unit circle of 0.4226 and minus 0.9063. So if I use inverse sine on minus 0.9063, I get, so I look in the table, 0.9063 goes with 65. So I can either report this as negative 65 degrees, or I can take 360 minus 65 degrees. So 65 degrees is the first quadrant reference angle. And this would be the theta that I'm looking for. So that would be 295 degrees, or negative 65 degrees. You can use this with, you can use your calculator, and your calculator will give it to you in degrees or radians, depending on what you have your calculator set in. And we can actually do a little bit more. Let me do a couple of examples that are a little bit more complicated than what I gave. So if I have sine of inverse sine of 0.2193, because sine is on the outside, I can just cross that off and get 0.2193. Like I said earlier, sine is opposite over hypotenuse. That's what goes into inverse sine. So I could put like 2/7 here. And because sine is on the outside, that's just going to cross off. And I'm going to get 2/7. Okay. Now, if I put the inverse sine on the outside and put inverse sine of pi over 9. Now this isn't in the table, so I'm going to have to use a little bit of math to figure it out. Since this is in quadrant 1, I just cross it out and get pi over 9 because that's in quadrant 1. And that's how it works when it's in quadrant 1. It also has to be between minus pi over 2 and pi over 2. So if you had a quadrant, anyway, so if you had inverse sine of 1820 over 9. Well, 20 over 9 is in the first quadrant, but it has to also be between pi over 2 and minus pi over 2. So this is going to be, it's going to return 2 pi over 9, because what happens, here's 18 over 9, not 18 pi over 9, and so I go up a little bit more to get 20 pi over 9. And so my first quadrant reference angle, that's, you know, like less than 360, is pi over 2. 2 pi over 9, sorry. Okay. Inverse sine of 7 pi over 11. Now you know why we had to do all that reference angle stuff. So 7 pi over 11 is here in the second quadrant. So there's 7 pi over 11. And so what's the reference angle is 4 pi over 11. So I get 4 pi over 11. It's positive because sine is positive in quadrant 2. Okay. So let's do inverse sine of 15 pi over 11. Okay, so that's in the third quadrant. So there's 11 over 11, and so I'm going to go 4 past. So I'm going to get 4 over 11, but in quadrant 3, sine is negative, so what I end up getting is negative 4 pi over 11. So that's my answer, minus 4 pi over 11. Okay, so that is all the examples I'm going to do.